Okay, welcome back, and today we are going to talk about the ball plate impact analysis. We are going to talk about the geometry and the mesh. So this part is dedicated for the geometry and the mesh. If you don't know how to navigate the LS PrePost software, I'll advise you to go back to our recent video that we made on how to navigate the LS PrePost software, how to install, and some troubleshoot things like the videos on how to configure LS PrePost, how to the basic errors that you're going to meet when working with LS PrePost. So that's basically that. Try to check that before coming back to this video. So today we need to understand a little bit what is it all about when we're talking about the geometry and the mesh, and we are going to build the plate and the ball so that we can make our impact simulation. Now, before we click a single button today, you need to understand what the simulation is actually trying to capture physically, you see. Because if you don't understand the physics, your mesh will lie to you and you won't even know it. And that's basically what we used to say, you know. When a ball impacts a plate, there are, let's say when a ball impacts a plate at high speed, there are a lot of things happening simultaneously, from the contact mechanics, from the wave propagation, from the deformation nodes. And we are going to understand a little bit why does it matter for the meshing. You know, the stress gradient at the contact zone is extremely high. This means elements near the contact point must be small enough to capture that gradient. A coarse mesh will give you a smooth but a false stress field, and you will miss the peak stress entirely. In simple terms, what am I saying? Let's say you are trying to make a ball plate impact analysis, and you are just using, let's say, 2 elements for the plate, and for the ball you're using, let's say you're using 50 elements for the ball and 2 elements for the plate. What happens is that when the ball comes and impacts the plate, in fact, initially you think the number of elements that you're using for the plate is accurate, you see. But if you decide to change the number of elements maybe from 2 to 5 and the result changes, what you understand is that you had a way too coarse mesh, meaning that the result was not that accurate, so it couldn't capture the gradient of the impact, of the point of impact between the plate and the ball, you see. Yeah, that's basically that. So on the screen you have some governing equations, and why are we using the shell for the plate and why a solid for the ball, you see. So the simple reason why we are using the shell for the plate is that it is computationally efficient without sacrificing the accuracy of the global response, you see. Yeah, because most of the time when you are working on the ball plate impact analysis, computational power is very important. You see, when you are working on a multi-body SPC dynamic simulation, computational power is one of the most important things you need to consider, you see. And now, why are you using the solid for the ball? Like a shell element on a solid sphere will be physically incorrect. It will represent a hollow pressure vessel, not a solid impactor. That's it on the screen. So take the time to check. Basically, take the time to check the Midlin-Reisner theory, and you'll understand what we're talking about here. Now, not too much blah blah, let's go into it. You go to FEM, and when we are FEM, we go to element and mesh. So we are basically trying to create, first of all, our plate. You are going to shape measure, click on shape measure, and now from shape measure I have some parameters already introduced here. So we are going to, first of all, arrange these parameters. What we are going to use at the level of the entity is the for-n shell. Why are we using the for-n shell? Because you always need to say why. Why are we using it? Why not the box shell? Why not the cylindrical solid and all of that? We are basically using the for-n shell because we are meshing a flat plane. like it is the most computationally efficient shell in explicit dynamic simulation. It uses reduced integration with hourglass control. Boom. For hourglass control, you are going to see we'll be interpreting the result further. Yeah. So basically, what we are going to do is from the coordinate system that have been from the coordinate systems, we are going to input it inside our shape measure. And please, the placing the brackets here was intentional. You see, I just want to let you know that when inputting the coordinate system, we don't need to put the bracket anymore. So I'll remove all of the brackets, add some space, remove all of the bracket, add space, remove all of the bracket, add space, space, remove all of the bracket, space, add space, and okay. Now, for the number of elements, we are going to start with 20 by 20. That is 20 in the x direction and 20 in the y direction. Now, for the target name, we are going to call it the plate. For the target plate, for the part ID, let's call it 1. For the element ID, let's say 401, and for the node ID, let's say 501. Why am I emphasizing on changing the element ID and the node ID? Because if you have the same value for the element ID and the node ID, what happens is that LS PrePost will override one value, and it will give false. It will give when you will be trying to, in fact, to process your result. What will happen is that you always have errors because without knowing, LS PrePost have override one of the two. You see, that's basically that. So we are going to create it. See what happens. We're going to accept, and now we are done. This is basically that. And the mouse gestures, you already know from the last episode. I will just click on shift and I'll be zooming in, zooming out. When you click on shift to zoom in and zoom out, you are not on wireframe mode. If you click on control, you zoom in and zoom out, you can still do it. Like shift or control, you're not on wireframe mode. But now if I click on shift or control and I pan, what basically happens is that now I'm panning but on wireframe mode. If you want this mouse gestures, please make sure to watch the last video. Now let's create the ball. You go to FEM, element and mesh, shape measure, and now from here you are going to use the sphere solid. Okay, now why are we using the sphere solid and not the sphere shell at level of the entity? Now we choose the sphere solid, not the sphere shell, because a sphere shell will create a thin wall hollow sphere, like a ping pong ball for those who play ping pong. Using a shell here will give you incorrect mass, incorrect stiffness, and a completely wrong impact response, you see. So that's basically why you're using a sphere solid. Now we know the radius the radius is 4, the density 5. We are going to use the center of the sphere 5, dx in the dx direction 1, dx direction in the y direction 1. Okay, we are going to call it, the target name will be the ball 2. Okay, we are going to create it, and that's a preview. We are going to accept, and we are done. Now after we have finished creating it, what we do is we are going to save it. So we go to file, save as, keyword. Now you need to check the last video to understand what is keyword definition and what is binary D2 plot, you see. So we are going to save as a keyword file, and I already have a file where I save my documents. So I'm going to browse, and basically the first error I want to do is to save it without underscores and using something else, that is spaces, points. We don't need that because LS PrePost don't open those kind of files, you see. You need to save it using underscores. Ball plate impact analysis 1, or it depends on you on how you're going to save it, you see. I already saved mine, so I'm not going to save it anymore. Now, the second thing you need to watch out for is the output version. The output version will depend on your server, your server setup version. Meaning that what, if you go and save it maybe with the most recent output version, your server is not compatible with that, it won't open the path. So take that into consideration while saving the file. Also, things that you need to watch for is let's say here when it comes to the feature tree, you see that the plate there's a 1 bit in front of the plate and there's a 2 in front of the ball. Why is it important? Because if you have 1 on plate and 1 on ball, what will happen is that LS PrePost to either merge or override during your initialization step when you want to solve, and it will cause a lot of errors. So take that into consideration. And also, like I was saying, another error is if you check here, you will see that the distance between the plate and the ball is, let's say it is 1 meter. This 1 meter was not placed for convenience. You see, you need to understand why is the 1 meter placed, and it is placed because we are definitely going to create an impact analysis. So take the time to consider if the ball and the plate are overlapping, because if they are overlapping, you are not going to have your result, and you will not even be able to launch a ball impact analysis. You see, an impact analysis, that's something you need to take into consideration. So from what I can say is most beginners think meshing is just drawing shape, but the truth is it's not. Every decision in meshing, the element type, the element size, the numbering, the body separation has a direct physical consequence on your result. The 1 millimeter gap between the plate, like I said, between the ball and the plate was not placed for convenience. It's a contact stability requirement. And the 20x20 plate mesh is not an arbitrary grade. It's your first engineering judgment about the spatial resolution versus the computational cost, you see. And that's why I usually say you need to think before you click. And for you to think before you click, you need to always ask why. Why am I doing that? Why am I clicking? You see. So that was that for today, and I think in the next episode we are going to understand how to place the boundary conditions and all of that. So see you in the next episode.